Hi, everyone. A very warm welcome to this session of Let Us Talk It webinar. We rather like to call it a zipinar for the simple reason that we try to give to our audience, to our attendees, as much as we can. How? That we try to make it a 1 hour worthwhile spending with us, giving you different topics, different speakers on different topics, and which are very relevant in these days. And we try to put in motivational, inspirational, technological, health, anything and everything under the big blue sky. But to make it a success, we need your cooperation as well. That's by attending these webinars, giving your feedback, giving your comments on social media. We go live on YouTube, Facebook, and LinkedIn. And if you have any suggestions, or if you want to be a speaker in these webinars or zipinars, as we call them, then please do comment us or let us know by emailing us at webinar@letustalkit.com. And we don't stop it here with all the people that join as professionals talking about work and life. We want to also make the future more empowered and enhanced. And how do we do that? We do it by empowering our youth. Empowering our youth in a simple way that we can is just trying to make them aware of some topics which is worth to think. Different topics ranging from famous people, from inventions, from moral values, anything and everything that our youth want to discuss. And to do that, we do our proper prep sessions, and we have divided our youth into two groups, a younger youth group from 6 years to 11, and the older youth group from 12 years onwards. And they have their proper prep sessions, and then they go live on YouTube, Facebook, and LinkedIn. How we go live? Just similar to this, alternate Fridays for the younger group and on Saturdays for the older youth group. For this Saturday, for the older youth group, they will be talking about natural forces, disasters. So that's how we try to give back to the community. And if you have any question or you have a kid that you want to join them, please do email us at webinar@letustalkit.com. So having said that, we welcome you once again to this session of our Zipinar, professional Zipinar, where we have professionals who have taken out their time and have put in effort to come in front of you and share their experience. If you gain from anything from them, please do share your comments and feedback, as I told earlier. And today's topic, first topic would be introducing CORPS, as CORPS, the 5 pillars for a robust cloud architecture framework. And to give this presentation, we have with us Muthukumaran Devadasss, and he is a blogger, software and mobile application architect. And he was not very keen on giving any more introduction about himself and being forced. That's what I got from LinkedIn. He is a dynamic, accomplished software architect with 16 years of experience in designing and implementing enterprise and cloud native applications in Azure, along with hands-on experience in .NET Core, Kubernetes, and Azure DevOps. So that's a lot to begin with. And we hope that you will enjoy our session with Muthu. Over to you, Muthu. Absolute pleasure to have you. And we welcome you to the session.
Hey, thank you very much. Let me start sharing my screen first. Okay. First, a few words about myself. My name is Muthu, and I am working as an architect in a healthcare industry. I have a huge passion about the technology. So I always go after all the shining objects that are out there in the technology world, be it like front end, back end, mobile application. I'd like to call myself as a tech savvy person that trying to explore and trying to implement every new technology that comes out there. Also, I'm a vivid reader about the technology. I follow lot of tech feeds, try to get myself up to date. because in the technical field, we had to keep ourselves up to date and keep our heads high to understand and know all the important things that's happening out there. Um, by saying that, I'm here to present you about one of the most important pillars, important topics about the cloud. So in the cloud, I know we are moving very fast, right? Um, I know like everyone is talking about, okay, AWS, Amazon Web Services, Azure, Google Cloud, IBM Cloud. Everyone is talking about different things about cloud. But what exactly is that? What is that? So why, like some we know like, okay, cloud means it's a computer set of computers that is owned by like servers and owned by someone else. We just taking a lease and start deploying our software solutions in the cloud. Okay, which is good. But give me a second. I'm just trying to, yeah. So yeah, so by it's a someone else's computer. Cloud is nothing but like someone else's computer. But when we begin our journey towards cloud, we are always unsure about our solution. Are we choosing the right technology? Are we choosing the right network? Are we choosing the right configuration for our computer, like servers? Are we choosing the like everyone is talking about native technology? What is cloud native technology? We keep on doubting ourselves, which is for a good reason, because it is new. That's why companies like Amazon Web Services, Microsoft, and Google, they come up with something called pillars of web technologies, like pillars of like cloud technologies. Generally, they call it as a well-architected framework, which gives a set of guidelines for us to follow and revalidate our solutions in the cloud. So before getting started, I'd like to give this introduction because it gives us some level of heads up like about like what I'm going to talk about. Because first thing, you have to know what is cloud, then we have to move on like how I'm going to implement my solution so efficiently so that it supports my business needs. Okay, now move on to like what is COPS. Okay, that's what I was talking about. Many organizations struggle with validating their approach to the cloud. And since this is like a very new technology, we don't have a lot of documentation out there. So like Azure or Amazon, they have given us a COPS. Okay, what is COPS? Cost optimization, operational excellence, reliability, performance efficiency, security. So this is called COPS. So I have placed cost optimization in the center because if we do the right thing in the operational excellence and the reliability, performance, security, we'll be saving a cost. That's a very, very important thing. Because why it is very important? Say, example, okay. We have a dev test workload that we have deployed as a simple proof of concept to measure the feasibility of Azure. Okay. Now, we have never, initially, we have a separate team in the enterprise. We have a separate security team, we have a cost team who manages budgets, etc., etc., right? So how we are going to be sure about that my proof of concept is very valid in terms of security, in terms of cost, in terms of performance, in terms of reliability? How we know that, how we should, first we have to know like we are asking the right questions, and we have to know like what are the metrics that are available, and we have to interpret it in right way so that we can do our job very well. Because now, being a cloud native developers, we cannot just do the development and deploy our code. We have to consider all these aspects of the cloud. That's why this is like a 5 pillars. So before getting into any development, we have to be very, very thorough about these pillars so that when we do our work, we can consider all these aspects. So as I was talking about, cost optimization is very, very important aspect in the cloud. Okay, why it is very important? In the old time, not in the old time, like still there are companies out there not using the potential of the cloud, right? So still, like when we buy a server on our own and put it on our data center, it means that that account that gets accounted in our capital expenses, and over a period of time it gets deprecated, but it takes time to get deprecated. But when the organization adopts the cloud platform, it will be part of the operational expenses. That's very, very important. It's part of the operational expenses, and those operational expenses gets reflected in the balance sheet every year. So it's kind of, like leasing. Like I lease a building for my business, so it's a part of my operational expenses. So it is an expense, non-recoverable expense. Okay, same thing with cloud. I'm going to lease the servers, I'm going to lease the service from someone else like Azure or Amazon Web Services. So it goes under operational expenses, and it's going to be like a huge impact. Okay, so how we can do that? First thing, plan and estimate the cost. So estimation is very, very important aspect here. So say I wanted to move my application to the cloud. So what are the things, what are the questions I can ask? Okay, can we move the existing application as it is? Do we need to make changes to application to support cloud migration? Because if we need to make changes, it is going to be additional cost. Do we have a required skill set? Okay, I'm a .NET developer or a Java developer. Can I just go and deploy the code in the cloud? No, right? Because we may need a support from someone who knows cloud very well. So we have to ask the right questions and write the, estimate the efforts correctly, because it's going to have a huge impact in the cost estimation. Okay. Then another important question, like a provision with optimization. What is provision with optimization? So what we have to is like when we have deployed a service, okay, I decided I deployed the code, I put it on the cloud. So how can I optimize the thing? We have to regularly review to see if the expense are appropriate for the resource requirements. How can I say that? Say, for example, there are two concepts out there. I just don't want to get deep into that, but I just want to say like we have a platform as a service and infrastructure as a service. So if you use a platform as a service, it's going to reduce a lot of operational costs. So what is the operational cost that gets involved in the platform as a, like in the regular? Okay, I own my own server, and I have to hire a person who knows to maintain those servers. And it's a Linux machine. There is a security threat, so we have to patch it. So we have like say we have a 50 servers, and at least I need like a 5 to 10 person who actively maintains the integrity of such a network of computers. But in the cloud, especially if you are going as a platform as a service, like the service provider, the cloud provider, Microsoft or AWS, they will be taking care of all those maintenance. They will patch it. They will make sure it is secure. This goes hand by hand. They'll be taking care of all the patching. So it is going to reduce a lot of operational costs. In other words, if you choose to like, okay, give me a server, but you don't do anything, I will manage my server. It is called like infrastructure as a service. So in that case, we have to maintain the patching, upgrading activities ourselves. It is going to cost more. So choose between, when you have to choose between platform as a service or infrastructure as a service, I would recommend to go with a platform as a service, so that we can focus on our application development rather than maintaining those servers. This is particularly very helpful for the startups because they don't have a lot of money and they don't have a lot of resources to work with it. Next one, maximize efficiency of the cloud spend. What do you mean by that, right? So it's in my company, okay, in XYZ company, it's very common practice, even for like a small web API, they just request for, hey, can I get a 8 GB RAM, 2 cores, etc., etc. But if you look at carefully, that service is going to run or in a peak hour, like maybe like 1 or 2 hours per day. That's it. And the amount of work that service is doing is very, very less. In those scenarios, like why we have to like allocate 8 GB dedicated RAM and CPU, and which runs only like 1 or 2 hours per day and sits like 22 hours idle. Okay, we cannot approach cloud with the same mindset because every minute, every second counts in the cloud. So you have to make sure what your application requires, because most of the APIs may require like a 512 megabytes of RAM. That's it. So you have to be very, very sure to estimate your hardware correctly. Okay. Then we have to identify and eliminate the costs. How I can do that? Okay. Like I said, there is a server that sits idle most of the times. We have to find a way to optimize that. How can we share those servers with the other applications? That's one of the important daily. It's going to save like at least like $100 to $200 per month for a business. Then, say for example, licensing cost. When you are using a cloud service, most of the time it comes with a default license. You don't have to purchase that. But sometimes we just purchase license and we forget. So we have to review those like more often and eliminate those additional licensing costs. And the storage is cheap, but in the cloud, there is a way to make it cheaper. So if your data is not required, like if the data is not required more often or getting access more often, we can move those data to an infrequently accessed storage, which is very, very cheaper. So that's one of the way to eliminate the cost. And unnecessary build environments. It's very, very common in an in-house data center to have like 5 different environments. Okay. Like I need a dev, I need a testing, I need a pre-prod, I need a sit, I need a prod, like 5 environments. We absolutely cannot have that many environments in the cloud. If you need a environment to test, spin it off, test, shut it down. Spin it off, test, shut it down. That's how it should be working. This is some of the ways to save cost in the cloud. So when you are starting your development, or when you have started your like cloud journey, this is one of the most important fact you have to consider. I think we are running out of time, so let me go a bit faster. Second one, operational excellence. Operational excellence is very, very important. What is operational excellence? Okay, like I said, how quickly we can spin up the environment and bring it operational. Okay. So in general, right? So in a regular world, we have a team. Okay, hey, I need a server. Then we go back to some other team. Hey, could you please install these applications in there, like a Linux administrator? We ask them, they do that. Then go to firewall team. Then they will open up the firewall. Then we go to a database team. So it takes a lot of steps, right? So how can we make it easier? So create it as an infrastructure as a code. Okay, we have a lot of ways to automate these steps. Okay, we can just open up a YAML file. We can say, okay, hey, I need this server, I need this software in that machine, and I need this firewalls needs to be opened, and I need this database needs to be created, and take this backup and restore in that database. We can automate all those complete steps, and someone needs an environment, spin it off. It is available quickly within 5 to 10 minutes. That is very easy. It saves a lot of money because we don't have a human resource, except one person just clicks a button there. That's a huge benefit. It is something like we have to consider, because most of the companies, they are thinking cloud, they are coming with the same mindset with the internal data center mindset and doing everything manually in the cloud as well. No, you don't have to do that. We can automate everything, and we have plenty of options available, and all the cloud providers supports automation of these kind of repeated steps, which is called like infrastructure as a code. And because right, like human is the very costliest expense in this workflow, because we are talking about like 6 different people working on setting this environment up and running. By automating, we can eliminate all those costs. Okay, then testing. So we can testing, how it can save the cost, or you don't understand, right? Yes, testing. If say you have identified a potential performance issue, potential security issue, like a potential threshold, bottleneck in the test region, you don't have to suffer on the production. So it is going to be very important step. So I would say like testing is one of the important aspect of the operational excellence. Next one, performance efficiency. This is a third pillar, right? This is one of my favorite topic, because I feel myself like I'm good at optimizing performance. So let's give me an example. Start with an example. Okay, you are working for Apple, and tomorrow is new iPhone 13 release. So what happens behind the scene? Why Apple takes down their website before releasing their phones? Okay, influx of the traffic will be high on the day of release, but are we going to get the same traffic every day? No, right? How we are going to manage that? How we are going to design a system that is going to help us to do this right? Okay, so we have an option for this as well, like scale up, scale out. What is scale up and what is scale out? Scale up means just increasing a RAM or CPU or a storage within a single machine. We have one machine and we are just improving the CPU performance, migrate from like a single core to dual core or a 4 cores, and increasing the RAM to like a 16 GB to 32 GB, etc., etc. That is called scale up. And scale out. Scale out means adding a multiple computers to the network. Instead of like one computer handles all those traffic, add multiple computers so that the traffic can be balanced and distributed evenly to all the computers. And it comes with, obviously, it comes with complexity. We have to include a software or hardware-based load balancer to support this architecture. I know, oh, additional cost? Yes, additional cost. But look at this way. Even if one computer goes down, we have 9 other computers to support the load while our team is working on to fix the issue. We have 9 computers that supports the network without any disruption. So it's a huge performance efficient, right? Next one, auto scaling. Auto scaling is very popular in the cloud. So what is auto scaling? This auto scaling helps you to answer the question that I asked you in the beginning. The traffic will be high on the day of release, but we are not going to get the same level of traffic every day, right? So in the Thanksgiving, the traffic will be high, but normal Monday, there will be very minimal traffic. So that's when this auto scaling comes into the picture. So it dynamically helps you to allocate resources based on the demand. Okay, Thanksgiving, I need 50 virtual machines that needs to support order processing. But it's a regular Monday, yet another Monday. I don't need like 50 machines. Maybe one or two should be more than enough, right? So that's what this auto scaling is helping us. The next one, optimizing the network performance. So another example, consider Amazon Prime Day. Okay, last Prime Day, Amazon has processed 20 million transactions in a day. How we are going to handle this much volume? With like whenever there is a order, right? Our backend has to process that order efficiently. But can it handle this much workflow? That's why we just put like a messaging queue mechanism in front of our APIs, so that we don't care, like whatever the order that comes in, that gets queued in our like a Kafka, it gets queued. Then the backend, what period of time it picks up the data and process. So that's how we optimize the network performance without worrying about missing the orders. Then optimizing the storage performance, right? So we can have like an efficient cache. You can cache the data so that gets served immediately to the user faster. And we can partition the storage so that we can immediately go and get the data, whatever we need immediately. And finally, we have to identify the performance bottlenecks in the application. That's how the testing also comes very, very important. So it's not only on the server side, our application may also should be capable of handling that much traffic. And sometimes like poor memory allocation handling in our application may cause the disruption, or we don't have a right index at the database. It's going to slow the application very much. So we have to identify which layer of our application is causes the slowness. The next one is a reliability, right? So when we are like, say for example, another example, because it makes easy to explain. So in healthcare organization, right? The clinician, like us, I'm working on the healthcare, so it's my favorite example. So like a clinical guys and the caregivers, they cannot afford to take an outage. So there is a little tolerance of the downtime there. Like e-commerce, imagine a downtime during a Thanksgiving sale. We are going to lose thousands of dollars every minute. So when we are designing a system, we should account for a reliability as well. Okay, so how much commitment we are going to make it to the customer? That's very, very important. Anything can go down, like a hard drive can fail, bad deployment, data center goes down. Anything can happen in this world. So how we are going to design? Say for example, we have a multiple servers, like how we can design a highly available systems, right? So we can use Kubernetes, because Kubernetes can help us to maintain our target goal. Say for example, I need a three like I need at any given point of time, I need three pods needs to be alive and support the application. And one goes down, Kubernetes detects and automatically brings another pod alive, so that there will not be any disruptions. And also we can have a multiple systems, and we can have a load balancers that actively detects the downtime and redirect the traffic to all the active systems rather than the failed systems. So reliability, so I know, right? So reliability is very, very, sorry. Yeah, so reliability is very, very important aspect, because that is going to help us to boost our business in the future. And fifth and final final pillar. Again, I know all the other 4 pillars. It's something like us over a period of time we get used to it. We at the time of designing our solutions we get used to it. But sometimes, or most of the times, we don't consider security until the day we go live. But security is very, very important, especially if you are working on the healthcare or if you're working on the financial institutions. Security is the first thing that comes into the picture. So we have these many layers. We have a physical security, policies and access, perimeter, networking, VM, applications, data. We have these many layers. There is a risk of getting exposed in every layer here. Let me quickly go through this, then I will wrap it up. So like data layer, right? So if you don't have a right encryption, someone should easily get access to our data, right? So we call it as encryption at rest. Not only when transmitting data from user computer to the server, it gets encrypted using SSL. But also when we are storing the data in the server, that time also we have to encrypt the data. That is called encryption at rest. So we have to use the strong encryption key so that even if someone gets access to the data, they don't know what they are looking at. The next one, application layer. Like application layer has a lot of weak points, cross-site scripting or a SQL injection, etc., etc. So we have to be very careful about application layer as well. Like a VM layer, like a computer, right? So there are a lot of chances like we install some open source software and some malware gets installed in the system. So we have to be very conscious about that as well. Like a networking layer. So unnecessarily, like say for example, very common practices like opening the SSH port 21 and which gets exposed and they get access to all the information that is available in the server. So we have to be very careful about what ports we are opening and how it is working. Okay. Then perimeter layer, perimeter layer means like, fortunately, this is handled by our cloud providers itself, like a denial of service, like hit the same server, hit the same endpoint again and again, so that no other can access to that particular endpoint. But our cloud providers are providing services to detect this and disable that IP address that posts all those requests. So that is one of the very important aspect as well. And policies and access layer. Okay, how I'm going to access the data. Probably like every one of us are annoyed of the frequent password changes, but it is very important, right? Because if you have an easily guessable password, then you are exposing not only your data, your entire company to the outside world. That is why we have like a two-factor authentication system, and we have a complex password requirement, etc., etc. So so that is very, very important aspect as well. Then finally, yeah, I'm done with my presentation with 5 pillars. Any questions? I know I kind of rushed through towards the end, but I'd like to give a chance to my fellow talker as well. Please let me know if you have any questions.
Yeah, thank you, Muthu. I mean, the word cloud puts us in a cloud situation, so everyone is aware of it. So, any questions from anyone?
No, that's a great presentation. Thank you very much. For the great insights.
Thank you, Srini.
Yeah, thank you so much, Muthu, for your time, your effort, and your well-spirited. You were so active, interacted, and yes, we will get our feedback from our social media, and we'll let you know.